Hello, welcome again. We are solving some questions of theory of machine. The topic is dynamics of machine or balancing. Question number 41 from grade 2014 ME-1 is a slider crank mechanism has slider mass of 10 kg, stroke of 0.2 meter and rotates with a uniform angular velocity of 10 radian per second. The primary inertia force of the slider are partially balanced by a revolving mass of 6 kg at the crank, placed at a distance equal to crank radius. Neglect the mass of connecting rod and crank. When the crank angle with respect to the slider axis is 30 degree, the unbalanced force in Newton normal to the slider axis is okay. So this is your slider crank mechanism and mass of slider is m, and suppose this crank is rotating in counterclockwise direction with angular velocity omega. Okay, so this is the position at any instant, and at an instant when the crank makes an angle theta with the line of action of stroke. Okay, so as the slider is moving in this direction, so the inertia force will act in this direction, and the inertia force, if we consider only the primary acceleration, then the inertia force is m omega square r cos theta, and it will be in this direction. Okay, now to balance this inertia force, this uh, mass has been attached opposite to crank at a radius r, which is equal to the crank radius. As this is attached opposite to the crank, so it will revolve with the crank with the same angular velocity. Okay, so it will also create a centrifugal force in outward direction that will be equal to m1 omega square r. So which will have two components, that is m1 omega square r sin theta and m1 omega square r cos theta. Okay, now along the line of the stroke of the slider, the unbalanced force is difference of these two, m1 omega square r cos theta and m omega square r cos theta. So m is your 10 kg and r is half of the length of the stroke, that is 0.1 meter, and theta is 30 degrees. Okay, so along the line of the stroke, the inertia force is 10 into omega square into zero point 0.1 cos theta. Omega is 10 radian per second. Okay, and again m1 balancing mass is given as 10 kg, 6 kg. Okay, so primary inertia force is sorry. So, the unbalanced force caused by this mass is, or the balancing force caused by this mass is m1 omega square r, that is 6 into 10 square into 0.1. Okay, so as it has two components, sin theta and cos theta, so along this it will be m1 omega square cos theta, and inertia force is m omega square r cos theta. Okay, so difference of these two will give unbalanced force along the line of stroke. So that will be, as m is 10 and m1 is 6 and omega is 10 and r is 0.1 for both, and theta is 30 degrees, so unbalanced force in the line of stroke is your 34.6 meters. We have to find out the unbalanced force in the direction perpendicular to the line of stroke. So that will be equal to m1 omega square r sin theta. So m1 is your again 6. Okay, so as there is no upward force, so taking downward force there is negative force. Okay, so it will be 0 minus m1 omega square r, and omega is 10, r is 0.1 and sin theta, so that will be minus 30 Newton, or we can say 30 Newton downward. So answer is 30 Newton downward. Okay.